I'm going to talk about the women who helped build the internet. And to start off with a little bit about me, I'm a software engineer and I've been working at the BBC for 2.5 years now. And prior to that, I was actually working as an architectural assistant at Brighton and Hove City Council. So that was following my vocation after doing an architectural design degree. So quite different to what I do now as a front-end engineer. Whilst I was in practice, I felt like it was going to take a long time to become an architect. And I found CodeBar, and through that I discovered the instant gratification of coding and getting an instant result that way, and I quite liked that. Also in my spare time I like to do art and dance, and I'm a grounded aerialist, so the pandemic's kind of put a bumper on that, but as soon as we're able to see people again, I'll be back in the air. So why am I talking about this, and why did I start to look into this topic of the women behind the internet? So it kind of started when I started to learn to program and code. I used the internet a lot to find out all the answers to my questions, and I've done this my whole life. Any question I've got, I probably will Google it first. So that kind of led me to wonder more about the infrastructure and what's going on behind the scenes of this web and internet. So to satisfy my curiosity, I went to some books. The book on the left is Introduction to Networking, How the Internet Works. Talks about all the infrastructure bits that I probably couldn't recite to you now. It was very technical, and I found it helpful for a very small part of my job. But the book on the right is Tubes Behind the Scenes at the Internet by Andrew Blum. He was actually an architectural writer, and I think maybe even an architect. So he approached the subject in a very different way, talking about data centers and using stories of the people behind the creation of the internet. The book actually ends with him in Portugal on the beach, seeing the transatlantic cable being laid. So that was a good book. And if you see the slides at the end, there's two talks attached to this slide, which he has done for Google and TED. So this was good, but the people I was reading about, I couldn't relate to them for some reason. It was a lot of men, and a lot of men in academia who just, I didn't see myself in them, which is unfortunate. But I have seen the film Hidden Figures, which is about the women behind NASA. There's an engineer, programmer, and in this film I found I could relate to these women, and that led me to find the book, which I've kind of stolen the whole talk from, which is The Untold Story of the Women Who Made the Internet by Claire L. Evans. And all the women I talk about are mentioned in this book. It's good. It's written in like chronological order of the women, so it takes you through the history of programming and the internet. I think it might even start with Ada Lovelace, so it goes all the way back. The last half of the book talks more about the culture of the internet, so I stopped about halfway. I will admit that. And then the book on the right is Female Innovators at Work, Women on Top of Tech. Two of the women I talk about are interviewed in this book as well. That was really good as well, because it spoke more about their lives holistically rather than just their contribution to the internet. So it was nice to learn a bit more about them. So the first woman I'm going to talk about is Elizabeth Jake Feinler. Jake was her nickname. She studied chemistry and was working towards a biochemistry PhD when she moved to Stanford. And she had a big interest in data analysis and compilation. And in Stanford, she worked with a group to design a bibliographic system in Fortran. So Fortran was the first programming language to have comments in, and it was written on punch cards, which I can't even fathom having to write code like that. It probably wasn't as instantly gratifying as it is now. So that was while she was at the Stanford Research Institute, which is now SRI International. And then in 1972, still at Stanford, she moved to working on the ARPANET. So what is ARPANET? ARPANET was an early packet switching network as part of the USA's Department of Defense. The first message on the network was between, I think I've gone too far, there we go, was between Stanford University and the University of California, Los Angeles. If you were to try and drive that distance now, it would take you 5 hours and 10 minutes. So an internet connection between these two places was probably quite ideal for transferring information. And that first message in October 1969 were the letters L, O, and then the system crashed. So they couldn't complete the sentence, which was meant to be lo and behold. So in 1972, when Elizabeth started working there, she was actually recruited to work on the resource handbook. So this meant she had to go around to all the hosts and ask them for information about who they can get in contact with in order to figure out the connections between the nodes. And it was really like a people-centered way of doing it. Like you couldn't just go to Google, you had to ring up people to get your connections established. So in 1974, she moved on to work at the Network Information Center, ARPANET. So here she was really in charge of essentially the Google putting people where they need to go. So they'd ring up like the yellow pages and say, I need to get in touch with someone at MIT, and she would let them know how to do it. Her and her team would man hotlines 24/7. So there was a lot of time and effort that went into doing that before it became online. So while she was working there, you can see how much the network grew. It grew from just a couple nodes around the United States to a very complicated looking map, which I can't even count how many nodes are there. And in 1981, there were 213 host computers. So she was probably very happy when they moved the address book to being online and not having to answer that many phone calls. Elizabeth and her team were responsible for coming up with the .com top-level domain name system, and also a host of other ones, .edu, .gov, and .net, the other ones you've probably heard of. And in 2012, she was inducted into the Internet Hall of Fame. It's a quite nice video if you want to go back and watch that afterwards. Ooh, I've gone too far. So my next woman I'm going to talk about is Patricia Wilcox. So Patricia is the only woman that I'm going to talk about that wasn't in academia. She was actually a software engineer and also a caver in her free time. So she was a very successful caver as she was quite small and could fit where other people could not. So she could climb through small cracks and attempt things which other people were too scared to. So in 1972, she was the first person to go through the intersection previously unknown, which connected two very complex cave systems in the USA. And this was called the tight spot. And how did she and her team discover this is the interesting part of the story. So at home, Patricia and her husband were both software engineers, and they had a teletype terminal, and this was connected via the internet to a PDP-1 mainframe, just sort of like a wardrobe-sized computer in their office. And on the teletype terminal at home, they plotted the cave systems which they were mapping on their expeditions. Their terminal at home didn't have a UI, as in like a monitor, so they couldn't really see feedback as well as we could today. So using this, they plotted the cave systems they were exploring and managed to find this small juncture between the two of them, which Patricia was then the first to go through. So this was in 1972. This is long before people misused the internet that much. And I thought it was really interesting to see how you can use it creatively and misuse it, I guess, as well. It's like an important part of creativity is mixing two things that you didn't previously think go together. So caving and the internet managed to form this great discovery of this tiny juncture between the systems. She also, in 1989, explored creating graphics in text. So the graphics that she was exploring were mechanical engineering drawings. And I thought this was just quite an interesting extra thing that she did. But I haven't found much else about that. I think it was sort of essentially as though we'd write Medium articles now, it was a bit like that. So in 1975, between 1975 and 1977, her husband wrote the game Colossal Cave based on their expeditions around these cave systems. So that's another way. I think they were both quite creative and both managed to make some quite cool discoveries from their hobbies. And yeah, I'm going to move on to Dr. Lydia Perlman. Dr. Lydia Perlman initially studied maths at MIT, and she started to work towards her PhD, but had never written a thesis for it. She then started an undergraduate research opportunity at the Logo Lab, and here she wrote Tortoise, Tortis, which was a kid's version of an educational programming language, Logo. She actually ended up stopping her work on this because she didn't feel like she was being taken seriously as a scientist. And after that, she started working on routing protocols at the ARPA packet radio network. After she started working on that, she finally completed her thesis. She thought it was quite easy after having to write all the protocols for her job. So one of the most important protocols she wrote was spanning tree rhythm, and she wrote a lovely rhyme to accompany it. You can see it in the slides at the end, or read it now. I'm not going to read it. I'm so sorry. But I can tell you that the algorithm allows for Ethernet packets to travel around a system in a loop-free topology, so you're not going to get infinite loops forming. And this is in probably the OSI level 2, and I generally work in like 5, 6, 7, so it's not something I ever had to come across in my work before. So it was interesting to attempt to learn a bit more about this. And Lydia Perlman expected this technology and the Ethernet to last for another 1 or 2 years after she invented it. But it's actually still in use today. And although there's probably more efficient algorithms, protocols to be using, it would be very expensive to replace all the infrastructure we have. So it's still in use. In the one of the books I mentioned earlier, she talked about how she feels like people that do good work are often underappreciated, And she said she felt like her name was only known because of writing a book that lots of people in networking would have had. I think this kind of means you should advocate for yourself and advocate for the people around you when you think they're maybe not getting the recognition they need. And my final woman I'm going to talk about is Professor Dame Wendy Hall, with lots of letters after her name, lots of honours. I quite enjoyed her academic journey. She did a maths degree and then a maths PhD and then a computer science master's. So I think it's interesting that she went back to computer science after getting that far in maths. I think it's probably a more academic route that someone would take. So she's now a professor, and it's probably quite important to her that she had the degree to back it up. So in 1984, after completing her master's, she went to Southampton University and joined the newly formed computer science group there, working in multimedia and hypermedia. So multimedia is a combination of different content formats. So it's a combination of images, text, audio, animation, and videos. And hypermedia is essentially bringing all those content formats to the internet. So her group, I've gone too far again. Her group in 1988 created Microcosm. So Microcosm was a system which linked documents together. And the system also had its own viewers to read videos and images, a bit like HTML5, like inbuilt into our browsers. It was also able to make use of native programs. So if you wanted to open a Word document, it would allow you to do that in Microsoft Word. And something quite interesting about the system is that if you clicked on a link, it would open up a list of content formats. So you could make one link to multiple files. That will come in. That will be important a little bit later. So the gone too far. So this was probably before the hardware could cope. This was still in the 80s. There's a good video I've got in my slides of it being demonstrated, and that's where I found out the most about it, to be honest, because there's not much about it on the web now. So then what won out in the multimedia hypermedia war was Cerns www. So although Microcosm was made before, the backing behind www, having CERN behind it, probably helped it win. And this was the first website. So not as exciting as Multicosm would have made it. It is just text with a couple of links to other text files. And this was first published in 1990. So one of the problems that still exists today in the format that we chose was link crop. So as I said, with Multicosm or Microcosm, the one link could link to multiple sources of information, which is something we don't have now. So across social media platforms, 30% of all shared links are completely dead within 2 years. So that would be people taking down servers or just restructuring their websites. So the links that were originally shared don't work anymore. So it was not a war, because her and Tim Berners-Lee got together in 2006 and formed the Web Science Research Initiative, which is a charitable trust which aims to develop global development of web science. So she also went on to get many more accolades from many universities and went on to do other things in her life. She talks about AI a lot now, and She still works at Southampton University, and she's also the chair of the Ada Lovelace Institute. So I don't have time for any more, but I want to talk about why role models are important. And I think I found these women interesting because I could see myself in a lot of them, especially Patricia Cortha with her hobbies of caving and misusing the internet. I think I could relate to her quite a bit. And the creativity she showed, and also the fact that a lot of these women made these discoveries but didn't necessarily need to shout about them. They were just quite happy to make them and to move on with their lives, and I quite like that as well. So Greek philosopher said, one of the best ways to elevate your character is to emulate worthy role models. So I think I quite like these women, and I'd like to follow in a lot of their footsteps with some of the great stories they have in their lives. And yeah, really struggling with these slides, but thank you. And if you want to read the slides yourself, you can see them on my Twitter. I believe they're pinned at the top.